So today in the lecture 3 we will begin Newton's laws of motion. So as we know that there are three Newton's laws of motion. One is the first law, which is the qualitative definition of the force. Means it simply gives the definition of force. What is the definition of force? Qualitative meaning of the force. Then second law, it gives the quantitative definition. Quantitative definition of force. All of you must have heard F equals to M into A. F equals to delta P upon delta T. And there is third law, which is the law of action and reaction. It tells about the nature of the force. Nature of the force means about some important points regarding the force. So see here, what is first law? Actually the first law, which is also known as law of inertia. Law of inertia. It is also known as law of inertia. What is the inertia? It is the inability of any body to change its state of rest or of uniform motion by its own. It is that inherent property by virtue of which every body opposes to any change in its state of rest or of motion, uniform motion, by its own. It's clear. So see here, what is the first law? Every body in this universe continues to be in its state of rest or uniform motion unless an external force is applied. Means as long as the external force is not acting, if the body is at rest, it will remain at rest. If the body is moving with a certain velocity, it will keep on moving with the same velocity. कब तक? जब तक कि force न लगाए. Means when you will apply the force on a body which is at rest, what will happen? It will come into the state of motion. Similarly, when you will apply the force on a body which is already moving, what may happen? Its speed may change, its direction may change, or both may change together. It is clear. So it is depending upon the manner in which direction force is applied with respect to the direction of motion. So on applying the force, if the body is at rest, it will come into motion. If it is already moving, its velocity will be changed. It is clear. So this is the Newton's first law of motion. Every body in this universe continues to be in its state of rest or of uniform motion unless an external force is applied upon it. And this is the definition of force also. As you have already studied the definition of force, force is that physical cause which changes or tend to change the state of rest or of uniform motion of any body. Means force क्या है? It is that physical cause which either changes or tend to change state of rest or of uniform motion of the body. Means force लगाने पर body की state change हो जाएगी. It is clear. Now after this, there is the Newton's second law of motion. Newton's second law of motion is actually the quantitative definition. Means by using Newton's second law, you can determine the value of the force, magnitude of the force. It is clear. You can find the direction of the force. So see here, according to Newton's second law of motion, rate of change of momentum of a moving body directly proportional to the force applied on the body, and it takes place in the direction of force. Means, as we know that when the force is applied on any body, what will happen? Normally its velocity will be changed. because in our course we have taken that the velocity of the body is smaller than 10 to the power 6 meter per second. It's clear, means on force is of such magnitude which cannot impart the velocity greater than this. So when the force will be applied, what will happen? Its velocity will be changed. Earlier it was u, now it will become v. And when velocity will be changed, what will happen? Its momentum will be changed. There will be the change in momentum. This change in momentum per unit time will be equal to the force. According to the Newton's second law of motion, change in momentum per unit time, which we also call as the rate of change of momentum. About the rate of change of momentum, I have explained in the lecture 2. So, from the Newton's second law of motion, F is directly proportional to delta P upon delta T. Here proportionality constant. What is proportionality constant? F equals to is 1. So we can write this way also. Delta P upon delta T. That is equal to, what is vector P? It is M into vector V upon delta T. So this is the mathematical form of the Newton's second law of motion. Mathematical form of Newton's second law of motion. Rate of change of momentum of a moving body directly proportional to the force applied upon the body. And it takes place in the direction of force. Means what will be the direction of the rate of change of momentum? It will be in the direction of force. It is clear. We already know that momentum will change. This will change only when the force is acting on the body. Otherwise, there will be no change in the momentum. Now, this we can write in the another way also. You have seen that vector F equals to delta P upon delta T. That is equals to M into vector V upon delta T. Now, if the mass of the body during motion remain constant, and usually in most of the cases it remain constant, it varies only when the velocity becomes more than this value. It's clear. When the velocity becomes more than this, then what will happen? Mass will be slightly increased due to the induced mass. So see here mass usually remain constant. This is one form of the Newton's second law of motion. Now in another form, what will you do? Since the mass is constant, therefore you can take out mass out. This is delta V upon delta T. And what is delta V upon delta T? It is the acceleration. So we can say that vector F equals to M into vector E. Now as we know that what will be the direction of force? Direction of force will be same as the direction of acceleration. Therefore simply we can write F equals to M into E. This is another formula of the force. One is this and another is this. Here we have assumed that mass remain constant. It's clear. Now after that, Newton's third law of motion. It tells about few properties of the forces. Now see here, what is Newton's third law? To every action there is an equal and opposite reaction. You see here, suppose these are the two bodies. This is the body 1 and this is the body 2. Traveling towards each other. When they will collide, what will happen? During collision, one will exert force on two and two will exert force on one. Suppose one is exerting how much force on two? F21. What is F21? Force acting on the body 2 because of 1. F12. 2 will apply force on 1. In what direction? In the left direction. 2 is applying force on 1 in the left direction, that is F12. Force acting on body 1 by the 2. So, according to the Newton's third law of motion, to every action there is an equal and opposite reaction. If we take this force as the action force, means the force which one has applied on the two is taken as action, then this will be reaction. And if we take F12 as the action, what will happen? F21 will become reaction. So according to this, vector F12, it will be negative to vector F21. It is clear. Now see here what is the meaning of this. So as already I have told, what is Newton's third law? To every action there is an equal and opposite reaction. Means both the forces of action and reaction will be equal in magnitude and opposite in direction. Both are equal in magnitude, opposite in direction. Number two, both are exerted by different bodies. One is exerted by the body 1, another is exerted by body 2. This force is exerted by body 1, this force is exerted by body 2. Then you can see here, both are exerting on the different bodies, acting on the different bodies. This one is acting on the body 2 and this one is acting on the body 1. Now see here, if I ask what is the net force acting on the body 1, so net force acting on the body 1 is only this, means it is F12. It's clear. What is the net force acting on the body 2? Net force acting on the body 2 is F21. Means net force acting on the any body is not 0. On none of the body net force is 0. You don't confuse that this is 0. It's clear. Vector F12 plus vector F21 equals to 0. But it does not mean that the net force on any body is 0. Net force on none of the body will be 0. क्योंकि ये दोनों फोर्सेज क्या हैं, अलग अलग बॉडी में लग रहे हैं. दिस इज एक्टिंग ऑन व्हाट 1 पर, ये किस पर एक्ट कर रहा है 2 पर. इट्स क्लियर. दे आर एक्टिंग ऑन डिफरेंट बॉडीज. नाउ देर इज वन मोर थिंग. फ्रॉम द न्यूटन्स थर्ड लॉ we can conclude that the forces always exist in pair. Forces always exist in pair. Exist in pair. In that one force may be visible and other force will be invisible. For example, this is the wall, and if you apply the force on the wall, what will happen? That force will be visible to everyone, but the force which wall is applying on you, that will not be visible. It's clear. But actually the force is acting. So forces always exist in pair. It's clear. This force you can experience. हम क्या है, दीवार पर बहुत तेजी से मुक्का मारे with great force, what will happen? You may get hurt. And why? Because the wall is also exerting the same amount of force in opposite direction. Because of that, you may get hurt. So, this is the Newton's third law of motion. Now, after this impulse, what is impulse? It is a very important term. What is impulse? See here, suppose this is a body which is traveling with 2 meter per second. Now you apply certain force here for 2 minutes. मीन्स 2 मिनट तक ये लगातार ये फोर्स एक्ट कर रहा, एंड इन दैट टाइम its speed has increased, velocity has increased in the same direction from 2 meter per second to 100 meter per second, and it is not necessary that it is increasing, moving in the same direction may be different also. Means in 2 minutes its velocity has changed from 2 meter per second to 100 meter per second. If you find the change in the dynamical state means how much motion has changed. So as we know that dynamical state, it is measured by the term momentum, and momentum depends upon the mass into velocity. This already I explained that momentum depends upon the mass of the body multiplied by velocity of the body. It depends upon m and v. So what is the momentum here? If you take momentum m, then it is 2m. Here it is 100m. What will be the change in momentum? Change in momentum will be here 98m. It's clear? Now this change in momentum had taken place in 2 minutes. Means in 2 minutes the momentum has changed by 98m. Now see, if we apply the force in such a way, मतलब अब second case, this is in the first case, we have applied a force of certain magnitude, the momentum has changed from this to this in 2 minutes. It is clear because the velocity has changed. Now if you apply the force in such a way and of such a magnitude that in 2 milliseconds, means within 2 milliseconds, velocity changes from 2 say 100. Velocity changed from 2 meter per second to 100 meter per second. Means within 2 seconds, 2 milliseconds, means in the fraction of second. In the fraction of second, velocity has changed. So see here, this change we define as the impulse. This change in the dynamical state is called the impulse. That the force has imparted this much impulse to the body. Force has brought this much change in the dynamical state of the body. Force has brought this much change in momentum of the body. If the same change occur in a very small interval of time, then that change in momentum, that change in the dynamical state is called the impulse. It is clear? That is called the impulse, and the force is called the impulsive force. Now you can see here, in order to bring the same change in momentum, in second case this change took place in 2 milliseconds. You have to apply a very great force. We have to apply a very great force which can change the velocity from 2 to 100 in 2 milliseconds only. In the first case, force is acting for how much time? 2 minutes. लगातार फोर्स 2 मिनट तक लगातार एक्ट कर रहा, पर यहाँ पर क्या है, फोर्स इतना ग्रेट है, इतना ह्यूज मैग्नीट्यूड का है कि वो यही चेंज 2 मिलीसेकंड में प्रोड्यूस कर देता है. सो द चेंज विच इज प्रोड्यूस्ड इन द डायनेमिकल स्टेट ऑफ द बॉडी, फोर्स विच इज द चेंज विच इज प्रोड्यूस्ड इन द मोमेंटम ऑफ द बॉडी in a very small interval of time, in the fraction of second, is called the impulse, and force is called impulsive force. So you can see here, What is impulse? When a great force acts on a body for a very small interval of time. This is the condition for the impulse. Then it produces a huge change in the dynamical state of the body. Huge change in the dynamical state means huge change in the momentum of the body, because the dynamical state is measured by the momentum over a very short span of time. This huge change produced in the dynamical state of the body is called impulse, and the force is called the impulsive force. And generally, this force is variable. Usually, it is variable. For example, when a ball is moving towards the bat, then the force which bat applies to the ball is variable. That's clear. As soon ball is moving towards the bat, here this is the bat. As soon as it come into the contact, force increases with time, and then it become maximum, and then it decreases. Normally it is a variable force. You can see here, if you draw the graph of force versus time, then it will be this. In the beginning, when both has come in the contact, then only the force will exert. When both has come in the contact, force is very small, but it increases, gradually increases, becomes maximum, and after that once again it will reduce and will become least, or it will become zero. So this force is usually variable, means not of constant magnitude. It may be of constant magnitude also, not necessary, but usually it remains variable. If it is of constant magnitude, then the graph will be like this. Over the time, force is constant, but the time is very small. Now you can see here. Here impulse is equal to what? Impulse equals to change in momentum. Impulse equals to change in momentum. It is also a vector quantity. Vector I equals to delta P. Now from the Newton's second law of motion, vector F equals to delta P upon delta T. So what is delta P? Delta P equals to F into delta T. And delta P we call as impulse. So this is the formula of impulse. Impulse equals to vector F dot in delta T. Means product of force and short time interval is called the impulse. F into delta T. It will be the magnitude. It's clear. Now see here. How will you find the same thing from the graph? Suppose this is F versus T graph. This is the F versus T graph. You have to find how much impulse is imparted from T1 to T2. So T1 से T2 तक टाइम कितना है, डेल्टा T कितना है, ये है. This is the delta T. In this time, how much impulse has been imparted? You find out the area under the curve. Area under the curve. What is the formula of area? We know that area is integral y into dx. So what will be impulse here? Impulse equals to area. Now you can see here. What is on y-axis? On y-axis there is F. So in place of y you will write F. In place of x, what will you write? You will write t. So it will be integral f dt. Integral f dt from t1 to t2. This is the limit. So this is also one formula of the impulse when you have to calculate from the graph integral f into dt. It's clear? So area under force versus time graph, that is called the impulse. Similarly here, how much is the impulse provided by the force? Impulse produced by the force from time t1 to t2. It will be equal to what? Area under the graph. What is the graph? How much is the graph? This. So this area. This will be equal to delta P. It is clear? So this is all about the impulse. Impulse means it is the change brought in the dynamical state of the body when a very huge force, great force acts on the body for a very small interval of time. It's clear? Now Newton's first law and third law is contained in the second law. So about this I will tell you in the next lecture, and then about inertial and non-inertial frame. And after that we will do the numericals of this chapter.